2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome, and welcome again. And one more time, we welcome you to Mathline Specialized Segments here on this lovely afternoon. I'm Ernie Roberts. I'm your host for this afternoon session. And say, what's Specialized Segments all about? Well, segments is kind of, it's a play of the word for geometry. In fact, we're going to look at segments today, but specialized because we're going to zero in on a topic, we're going to work it, we're going to hopefully have you understanding it a lot better when you look after this video than when you started, all right? So you take a look through with us, get you some pencil, get a paper, all sorts of good things to write with, maybe even a calculator might help out. But what we're going to do, we're going to take back no call-ins today. By the way, this is one of those days where we're just going to sit back, like I said, relax. Let's do some math, and let's have some fun. And what's our topic for the day? Let's see what that's going to happen. That will lead us to know where we're going. Coordinate your midpoints and endpoints. Coordinates. Aha, I got it. Coordinate geometry here probably. Midpoints, endpoints, all together. Here we go. So let's test this thing out. Coordinate plane, we're going to graph. That's kind of another word. Oh, we're graphing. Well, it's important to be able to graph. Yes, it is. So let's pick a point. 2 points, actually, because we need 2 endpoints in order to find a midpoint. I'm going to throw one right there. Oh, let's bring one right up there. That looks like a fun place to be. And by the way, when we're talking about midpoints, we are talking about line segment, not lines, not midpoint of line. There's no such thing, nor is an array. So we're going to just connect from point to point right there. Ooh, we're in the coordinate plane. There you have it. Now the question is, what are the coordinates of the midpoint? In other words, where does this thing break even? Where are you able to basically find a point somewhere on that line segment that's going to make both sides congruent, or both small segments once you divide it up? That's what a midpoint does, right? Divides the segment into 2 congruent parts, and they are also segments. So my thought is, eyeballing it, it's somewhere, I think it's right about there. And you say, Ernie, how'd you figure that out so quick? So, well, because you made the problem up, right? That's one of the things, but there's some rhyme and reason to what's going on here. And we're going to look at that. There's a formula for finding the midpoint, but I first want everybody to understand what it is about. We look at a segment. We have some coordinates here. We'll call it x1 and y1, because those are x, y, by the way, ordered pairs, right? You got it. Down here at the bottom, well, how about it? Second x and second y. Don't let those bother you. We're not squaring them. We're just simply saying first x, first y, second x, and second y. Now, with what we've got going here, the question is, what does the midpoint usually do? Well, it's usually the average in the middle. It's exactly in the middle, dividing those things up congruently. So we're thinking about some averages. So let's talk about that just a second, all right? We got a little bit of a moment here. We got a formula. You say, oh, yeah, okay. And I said something about averaging. That's what a midpoint does, especially when there's only 2 points involved. If you add them together and you divide by 2, it's an average. And that is going to be your middle. That's going to be your midpoint, if you will. So what do? You add the x's and y's together, or just add the x's by themselves? What do we do? Let's talk about it. A midpoint formula. And basically, it is going to be, folks, the average of the x values. And by the way, there are only 2 of those. And it's going to also be an average of the y values. You see, it's coordinates. They're coordinates. So there have to be 2 answers, 2 numbers, if you will, to make that ordered pair. So here we go. Average of x values, and we'll take average of the y values. And there are 2 of those because endpoints. Those are the 2 endpoints of the segment. So, if we marked it x1, y1, so let's go for it here. To get the x average, by the way, we're going to big coordinates here. Big coordinates right in the middle here. That's how we go there. Formula. So what is the midpoint formula? It's the average of the x values, the average of the y values. How is it determined? That's what we're going to put up here to get the formula. So in order to average, you're going to take your first x, you're going to add it to the second x. How many are there? Oh, duh, 1, 2, right? Divide it by 2. There's your new x coordinate. Now, what about our y value here? We take our y, it's the same story. Don't want to do it any differently. It works for one of them, it's going to work for the other. And again, notice I put my first y plus second y. It doesn't matter which order we put them in, by the way, does it? Absolutely not, because when you add them together, it's commutative property. All right, you can add them whichever way you want to. And then we'll do the same thing. We'll divide that result by 2. So there's your formula. Think of it, average. Add the two numbers together. You got two numbers there to worry about, two endpoints. Add the two x's together, divide by 2. Add the two y's together, divide by 2. My goodness, is that easy or what? That really, really is an easy plan to do. So let's go back just a second here to our original problem. Now that I have an idea what I'm going to do, I'm going to average the x's and I'm going to average the y's. Let's take a look at the coordinates of this first little guy here. Looks like I went over 3 and up 3. Well, that was easy. The only thing that kind of gives us a problem there, now we got 2 3s, so you don't know which one I'm using. I'll be sure to tell you. And down below here, what do we have? I see a, ooh, which way did we go first? We didn't go anywhere, did we? And then we end up with -3 for the y. So we went down. We didn't go anywhere left and right, but we went straight down. Now the question is, that thing looks like, you know what it looks like to me? It looks like it's smack dab in the middle of 1 and 2. So I'm going to go with 1.5. And it looks like it's sitting dead on our axis there. So you know what? That could be a 0. Let's see if it works out that way. Use your formula. Let's go with the formula here. We got x1 plus, now don't put a y in there. I know it's so tempting to write x plus y, but we aren't going to do that. We're going to add our x's together, and we're going to divide that result by 2. Then we're going to practice in just a minute without a grid. Can you believe it? Without a grid, we're just going to use the formula. And in addition to that, we're going to put our y1 plus y2 right there over 2. And remember, the big parentheses are there to say, basically, we have a new xy coordinate. That's the idea. I have so many students who think, after they've heard slope, they've heard midpoint, they've heard distance, they get them all mixed up, all discombobulated. First of all, folks, midpoints are the only things where you add together and divide by something. And in this case, you're going to always divide by 2 because there are only 2 values you're worrying about. x1 plus x2, go by 2, divide by 2. There are 2 of them. Same thing here, y1 plus y2. 2 of those, divide the result when you add it by 2. And you've got what you're looking for. So let's put our numbers in, because you're already going, okay, Ernie, cut to the chase. Well, we'll do that. We've got the x's. My first x is 3. My second x is 0. And I'm going to put that over 2. So you go like, oh no, that doesn't come out even, Ernie. Well, guess what? We have halves. It will work. It'll be fine. It'll be okay. Don't get too excited out there. Now, in the other conditions, we've got our y's that are working. I have a 3 again for y1 up there. Remember, there's y1 way up there in the corner. And we're going to add that to a -3, and we'll divide that result by 2. This is really simple. It's easy addition, isn't it? Just simply add together and, divide by 2. Got to remember your rules for positives and negatives, but 3 plus 0, that one's real easy. So we're going to pick up, looks like 3 over 2. I'm going to leave it like that for just a minute. I don't like fractions unless they're mixed numbers situations. If you're going to have a fraction, a mixed number or just a good old fraction is fine. But a 3 over 2 bothers me because I don't think of where is that. And I'm already saying some of my students are thinking, are we going to do that rise over run there? No, we're not. Okay, that is not a slope problem. This is an actual value of x. This is going to be an actual value of y. But what happens here? I get 3 plus -2. It gives me 0. And then I have some of my kids look at it and say, 0 divided by 2, I think it's 2. No! 0 divided, if you have nothing and you divide it 2 ways, you've still got nothing, all right? So 0 we have. Let's make that a mixed number, that 3 over 2. I'm going to go with 1.5. Some of you like the decimals. 1 5/10 is fine, 1.5. And keep your 0. And look, what we get? We went over 1.5 units. How about that? And we didn't go anywhere up or down. So that actually is 1. I'm going to put a 0.5 just for you folks who love decimals. And a 0 right there. I'll leave the fractions here, leave the decimals there. But those are the coordinates of the midpoint. So that's where it comes from. It comes from one of our x's. What does our graph look like? Remember, it can only be midpoint of a line segment. Now today, we're going to hang with the midpoints. We may get to the point where we can find some endpoints. If we do, great. If not, we're going to get some good practice out of these things. And again, you say, Ernie, why do you practice things? Because you get good at them that way. You remember them. You do. You put them in the brain and you say, hey, I did 5 of those. It was worth my time to do 5 of those because I'll remember. I'll remember that lovely formula he gave us. And the formula that your textbook gave you, the teacher gave you, everybody gets the same formula because it is. The midpoint formula is the average of the x's divided by 2. Not the average divided by 2, but the average, which includes dividing by 2. I want to make sure we got that straight because some of you are going, did he say average and then divide by 2 again? Yeah, he did. And that was probably not what you wanted to hear. So let's go to our formula one more time. Actually, a few more times here. Let's practice these things. We've got x1. The formula says we're going to take our first x plus the second x, and we're going to split it. We're going to average it. We're going to divide by 2. However you want to look at it. All right? It's a sum. Divide by 2. Over here, we're going to have the y's. We're going to add them together. And again, those 1, that means first and second. That has nothing to do with squaring, has nothing to do with powers, okay? It's just a subscript, we call it. It's the first and the second. And again, we're going to take that result because we're looking for the average. We're going to divide it by 2. Now, some are positive, some are negative. Yeah, we can have negative coordinates, okay? We can go up and down or left and right. We've got positive, negative, all sorts of directions. We come back with 0 like we did in the last problem. So don't get excited with your answers here. If you want to really check them, put them back on that grid and see what happens when you graph. So speaking of which, let's put these numbers in there because this is all about substitution. Ernie says, watch out. Those are x's. They are the first coordinate in the ordered pair. Don't make that mistake. Some of my students forget. They start putting x1 and x2 in the same coordinate. Doesn't work that way. Over here, the same thing. Put a y2 on the end. You've got it. 1, 2, 3, 4 numbers. 1, 2, 3, 4 things to be substituted, and then compute an answer. That's all there is to this formula. Well, almost all of it is. Let's see what we're going to do here. We're going to take the 2 x's, which I get 4 plus negative 2. And some of you are probably already saying, can we do that in our head? If you can do it in your head, more power to you. I always like for students to show me where they're coming up with it. Like there's that 2 kind of hiding down under the Mathline thing. Let's see if we can bring it back out there. There we go. Hello, 2. Now, let's see. We've got negative 5 plus 3. And we're going to see what happens there. Got plenty of room to the right, so why don't we just go ahead and put it out there. And again, here comes the part you can do in your head. Actually, some of you said, I could have done that without writing the formula. Once you get the formula down, probably not much need to rewrite it over and over unless your instructor or teacher wants you to do that. And if they do, go for it, all right? You know it. Show that what you know. Show what you got, what you learned. Now, putting these numbers into play here, I've got 4 plus negative 2, which that's going to give me 2. It's just like saying 4 minus 2. And divide that by 2, I'm down to 1. All right, so I'm a 2 over 2 there for the x value. Now, hang out with me on the y's. Hang out with me on the y's there. Negative 5 plus 3 gives me what, negative 2? Because the negative is bigger, isn't it? Absolute value of the negative number is bigger, so we're going to go with that sign. And goodness, let's think of negative 2. I think we did, right? You got it? Negative 2, let's divide that in 2 ways. We're going to have negative 1. There you go. There's your new midpoint. That's the midpoint. You say, is that all we do? If you want to check it, you put it back on a graph. It'll look very nice, I'm sure, just like ours did earlier. But it's, again, there's your endpoints. It's a line segment. And there's your midpoint coordinates. That means what we're going to do to get to it, folks? It means we're going to go to the right 1 and then down 1. And that's where you'll find where you're looking for. And again, it should be right smack in the middle of the, let's see, the 1 should be right smack in the middle between 4 and negative 2, which it is. Divides them evenly. And also going through here, what we got? Negative 1. That should be also halfway between there, all right? So you put them together, and it will be the halfway mark between negative 5 and 3. Midpoints, aren't they great? Aren't they great? It's very straightforward. The formula is not going to change, all right? The numbers may change with it, which obviously we're going to do, so let's do a practice shot here. Let's pick up another one here. Oh, I keep putting these even numbers, but we'll be good. Let's go for it here. Let's see what happens here. Ooh, they're all negatives, folks. Don't freak out, okay? Let's do it. Formula, have you got it yet? One more time. Let's write it down one more time. I've got first x plus second x, or we call it x1, x2, or x sub 1, x sub 2, all those good things. We add them, and then we divide by 2. Play the same game for the y's. y1 plus y2, we'll divide that by 2. Remember, this is just it looks like a big coordinate, because we're going to find an x value and we're going to find a y value. That's the game plan. So bring the numbers right on down. Remember, that's the first x. And some of you are going to say, well, could you call that the second x? Yeah, as long as I call that the second y. Got to match them. Keep the subscripts matching. That's what we call those little 1s and 2s. But this is a y1, okay, because it's a y combination. Here we go. How about it? X2 right there and y2, not squared, but just second x, second y. And let's plug them in, see what happens. Formula is very easy. Put that -6 plus the -4 right in there. Divide it by 2. Remember, it's a coordinate we're working on, so we're going to keep the parentheses. There's your x component. How about your y component? My goodness, what do we got? We got a -8 plus a -2. We'll divide that by 2. This looks pretty easy. You know why it's easy? Because you know your rules for positive and negatives. Exactly. -4 plus a -6 is going to give us a -10. Okay, now hold that -10. Got to divide by +2. We get -5. And yes, you can do that in your head if you are feeling so inclined. How about -8 and -2? That gives us -10. Oh, -10 also. So we divide that. Same old story. So where is that midpoint going to be found, considering where these are both found in the negative land? All right, so this definitely should have 2 negative values to be in between those, because all 4 of these values here were negative. And -5, is it right between -6 and -4? It certainly is, right smack dab in the middle. And when we look at -8 and between -2, it's another -5. Now, what does that tell me to do to find that point on the graph? Think about it. Remember, it's a coordinate, it's not slope, it's not rise over run here. This is x and y. So you will go what? Left 5 and down 5, and boom, there is your midpoint. Midpoint of this segment anyway. So you say, well, midpoint moves around a lot, or doesn't it? Yes, it does. Depends on what your endpoint coordinates are. So this is all about coordinating midpoints and endpoints. And if you really want to get down on it, put it back on that little graphing sheet, and you'll say, oh my goodness, it works very nicely. Very pretty here, all right? So let's see what we got else coming in here. Some of you are probably going like, well, what happens if they don't come out even? Well, let's find out. Let's see what happens. Those were coming out really nice and even, integer values. They're still probably going to come out even, but a little twist and turn here. Let's see what happens. Formula, once again, it is not going to change today. It's going to be an addition formula. It's not going to change next week either, folks. It's going to be add the x's together, divide by 2, and then come on back and do the same thing for your y values. Add your y values together and divide by 2. That's formula. It's midpoint formula. 4 times you think you got in your head by now? I said, yes, Ernie, we do. All right, so keep in there. Piece these together. Let's see what happens. I get -3 plus my 4, because those are my x's. I'm not going to put the x1, x2 on. I think y'all can figure out which one's first and second x by now. I'm going to put and divide it by the 2. And over here, we're going to play the game with 7 and -4. So I'm going to take 7 plus that -4. And we're going to play a divide by 2 moment. And here we have it. Both of these do not, quote, come out even as in an integer. All right, a positive and negative integer is 0. And of course, positive or negative gives you everything. But 0 is also a good integer. Don't forget about it. We had that in the first problem today. So let's see what happens with these, because they aren't so cool and pretty, are they? This would be, how about it? 4 minus 3 gives us 1. Then we're going to divide that 1 by 2. Well, you know what? If you divide a whole by 2, you're going to get a half. I was about to jump right in and say it's going to be a half. And there we have it, 1/2. What happens on our next one over here? Let's go for it. We have 7 minus 4, which is going to be positive 3. That's going to work good for us. Divide that by 2. I think you can do that mentally. If not, it's a good time to learn. 1 and 1/2, or 1.5, 1 and 5/10, how we all like to throw it out there and talk about what it is. Finish your coordinate point. We are good. Now you say, Ernie, where's that going to be? That's going to be a little bit between 0 and 1. It's not a full block, it's half block. So you're going to go to the right because that's positive, and then you're going to go up a block and a half to get to 1.5. And that's another reason why I really don't like to use 3 over 2, because sometimes people say, oh, we got to 1/2, now we're going to rise over run. That's not the game plan. So I like mixed numbers. They have a good reason. They make sense on a grid, on a graph. So there you go, 1/2. If you wanted decimals, sure, we could do it that way. We could put 5/10, and you could also go right there, because these came out even. These came out even. And truthfully, when you're graphing the numbers that aren't right on the block or right on the corner or right on the point there, so to speak, you're going to probably estimate where you plot the point anyway. But try to get close. Those are right in the middle. You got eyeballs, use them. Get that midpoint on. Get your midpoint on here, and it'll make life pretty easy for you. This isn't hard stuff. Really isn't. All right, let's take one more here. Why not? Let's take a twist. Boy, I just got my head all kind of going, wow, what are we going to do here? Let's take a look at this next problem. This one makes us think a little bit. It says, if 2, 5 is an endpoint, woohoo, 2, 5 is an endpoint. I think I want to get some graph paper. Hang on just a second here. This one sounds like something we're going to need to see. And why not? Let's do it. If 2, 5 is an endpoint of a segment and its midpoint is -3, 2, find the coordinates of the other midpoint. Mouthful, isn't it? So we've got an endpoint of a line segment at 2, 5, and we know the midpoint, but now we're going to go find the other endpoint. Well, that's got a lot of things going on here, doesn't it? So if y'all take my picture away just a second, let me slide in this little, I love when I can't move my hands as quick as I'd like to. Let's slide this thing in. Hold on. We are going to get this for you. There we go. Let's take a look at it. There we have it. And the storyline goes that we have the point 2, 5. So let's find it. Over 2, up 5. There it is. Y'all hopefully getting this done on graph paper also. Then we got this other point that's our midpoint, which is what? -3, up 2. So remember our 2 points here. Endpoint, we'll call it A, was at 2, 5. What does that mean? It means we go to the right and go up 5. Okay. This one, next one, our point M, we'll call for midpoint. Didn't say that, but I like it. M for midpoint was at -3, 2. All right, -3, 2 tells me go over the left 3 and then come up 2. Right there it is. Everybody with me? Don't leave me. Don't leave me out there. All right. How did I get there? Well, I did quite a bit, didn't I? So what I'm thinking here is I'm looking for what number is going to give us the average of -3. Well, I want to tell you something. That tells me we're going in a negative direction here. If I've got a +2 for this part and I'm moving in this direction, I got to keep going. So you say, well, Ernie, what's a good way to do that? I think you can just do it easily by, here comes that slope moment, even though it's really not a slope problem here. But just notice, you went down 3 and over how many here? You went down 3 over 5, all right? So let's continue the trend. Continue the trend first of all. In the Y, we went down 3, and, oops, I don't want to put that point there because that's not where it's going to happen. And then we're going to move over 5 more. This is where it's going to happen. That was just kind of a little intermediate moment right there. Don't worry about it. It's gone, all right? So bringing back my great ruler here. Thank you, Jim Sane. And let's pull it out here and see what we can do on this. I hope we can connect it. I tell you what, I may just try connecting it without the ruler. Just pull it out here. All right. There goes part of it. And there comes the other part of it. And there they connect and join together. It's supposed to be one long segment. Bring it back to you. Well, got a little out of joint there. We can pretty it up. There we are. Hey, it connects, doesn't it? So the idea is this would be our midpoint. This is the end point up here. This was 2, 5. So what are the coordinates down here, we ask? Well, it looks like we went over 1, 2, 3, 4, 5, 6, 7, 8. Ooh, we go all the way to 9? We went all the way to 9. We almost went off the board. Is that correct? Let's count again. I don't want to overcount. 1, 2, 3, 4, 5, 6, 7. No, we went 8. So we went over left 8 and we went down 1. So the coordinates of this point out here are -8, -1. Now you say, Ernie, can we do this algebraically? I think we can. Do we have enough time to do this algebraically, guys? I got 30 seconds, they say. We're going to have to wait till our next time. So that just gives you something to wait for the next week here. But we're going to figure out how to do that algebraically with a little simple pre-algebra moment. But also, I hope you see now what we're talking about. We got an endpoint, we got a midpoint. We can find that other endpoint. That gives us a thing to go on next time. So coordinate your midpoints and coordinate your endpoints. That's what we've been trying to do today. Hopefully this made it easy for you. And you know what? We will be back again, specialized segments with you once again the next time. See you then.